Hi everyone and welcome to this episode of Keipert Labs. In today's video we're going to be discussing the concept of reflection. Okay, so we've looked at this idea that light, so we're thinking about light, just quietly, that travels in rays. Well, that is straight lines, okay? Straight lines of parallel light, okay? So, now I'm totally not doing this with a ruler, but getting this idea that that it's a concept that we tend to imagine that light waves traveling in a particular direction. Okay, and so these light rays, these particular waves traveling in a certain straight line in a particular direction, are the ones that we seek to study. Okay, so we set up using whether we're using a light box with a slit card in one end, so that we only get rays that are traveling in a particular direction, or we use a laser where we're actually setting up a beam of light that only travels in a parallel direction, or whatever. That then we're trying to find ways to study that light. Okay, and so one of the phenomena that we're going to look at is this idea that we call reflection. Okay, so we're going to write up a definition for you now. Okay, so reflection is the rebounding of light off a surface. Okay, so that it can be, so that could be like in a mirror, a shiny surface where you're seeing an exact image, or even, we get it off dull surfaces where you turn the light on and then the light kind of rebounds or reflects off all the surfaces in the room, even if they're not mirrors or shiny. And that reflection of light is in all sorts of directions when it's on a rough or kind of opaque sort of surface, but it's still bouncing off that, which is fundamentally how we're able to actually see it, because the light rebounds off the surface and hits our eyes. Okay, but here we're going to be typically thinking about mirrors, okay, and the behavior of light at a mirror. So let's say we have a plane mirror, or a flat, kind of horizontal sort of mirror. Okay, and so then what we know is that then if we get a ray of light that we point directly at that surface, that then it will rebound back. Okay, that's the concept of why you would stand in front of a mirror when you're trying to check yourself out in the morning. Okay, that light rebounds off that surface. But what we as scientists are able to do is to actually study the behavior of that rebounding off that surface and to explore it a little further. And so what we do to actually we're gonna hit this surface with light at particular angles, and then see what happens. And so what we need to do is we need to establish an artificial right-angled line to this called the normal. Now, in science, this kind of line, normal is not, that it's typical or everyday, but the normal is that it's a line that's at right angles to a surface, or right angles to another line in maths. Okay, so that's why, so this is a 90 degrees. Okay, so let's say that we get a ray of light, let me redraw that. Okay, that's heading towards this surface at a particular angle. And that angle in here is 45 degrees. So it's 45 degrees to this this perpendicular line. What we then notice is that the light rebounds off this surface. Okay? That's not news to anybody. But if we were to measure this angle, we'd see that it's also 45 degrees. Curious, but nothing particularly revolutionary. Now this diagram that I've done is totally freehand, okay? I recognize that those angles aren't actually 45, but it's just representing that. Okay, so in case that bothers you, just keep that in mind. This is illustrating a point. Okay, so then if we varied up our angle, and we said, all right, let's make it at 30 degrees. To this normal, so it's a little bit more, it's almost a bit closer to being directly front on. Okay, I'm also not modeling the best behavior because I'm not using a ruler at the moment, so that's because I don't have one handy with me. Okay, the Keipert Labs studio is not as well stocked as you'd think. So if the light is hitting at an angle of 30 degrees and then it rebounds off this surface, what we notice is that that angle is also 30 degrees. Okay, so we had 45 degrees and 45 before. We have 30 and 30. Let's try a different combination just to see if this pattern continues to bear out. Okay, so let's try a shallower angle this time. Okay, so let's try coming in like this. Okay, and so let's say that this angle is now 60 degrees. Okay, and then lo and behold, the light rebounds off that surface at 60 degrees over here. So what we've demonstrated is a scientific law. Now, a scientific law is a predicted pattern of behavior, or kind of based on things that we're observing, that it's something that we can use to predict what would happen in certain situations. It doesn't explain it, it just says, all right, if I do this, then we'll see that. And so what we've established here is called the law of reflection. Okay, now what we say over here, this ray of light that hits the surface is called an incident ray. Okay, so whenever we're thinking about one light that is hitting an object or hitting a surface, we've got the ray of light that's on its way to it is called incident ray. And then over here, when we're thinking about a mirror, we have what's called the reflected ray. Okay, so it's the ray of light that has come off the surface, is heading away. And so what we then do is saying, all right, if I'm looking at this diagram, I want to be able to identify these particular angles. Okay, and I'm going to flesh this out over here once I do that. So if this is the incident ray, then this over here, this 60 degrees is called the angle of incidence. Okay, so turning that into a noun, whereas this is more of an adjective. And so therefore, then this is called the angle of reflection. Okay, so that the law of reflection states that the angle of incidence equals the angle of reflection. So no matter which angle that I set up, as long as it's hitting at this same precise point, that whatever this angle would be, the angle of reflection would be the same. So this is, I'll put it in brackets, relative to the normal. Okay, so this dotted line of at right angles to the surface. Okay, so it's this angle, and we're not measuring this one over here. Okay, because yeah, we don't see it bear out the same way. Okay, so make sure that you take close note of this law, that you remember it well, you treasure it always, because science is awesome. And so there we go. So now we've talked about this idea that light is reflecting. When light is reflecting, it is rebounding off a surface, such as a mirror, which might be flat or it might be curved. That we've seen that there is a pattern of behavior to how that happens. That there is an experimental law that we've worked out, that the angle at which the light hits the mirror is the same as the angle at which it leaves the mirror, relative to that perpendicular line we call the normal. Okay, so we're going to explore mirrors in a little bit more detail with some hands-on stuff that I can't show you right now, because again, the Keipert Labs studio is not as well equipped as you think it is, or would hope that it would be. So we'll get to play with the light boxes and actually see, all right, well, let's test this out, draw some diagrams, and let's have a bit of a play with some curved mirrors too. All right, thanks very much for watching. Bye for now.